Okay, today about project tool. So project tool is about the cache design. So you are required to implement a different replacement policy, like not recently used, random, or pseudo least recently used policy in the simulator. So I will provide a very simple single file cache simulator so that you can implement different replacement policy in that file. And if you can implement some batch policy, take it as a bonus. So the result, will be something like this. We have a different benchmark, different cache miss rate. This is the cache. The y-axis here is the cache hit rate. We have a different bars here. Each bar is different. Most recent used policy. As you can see that on course, for some of achieve the highest hit rate. So you need to download zip file from Canvas. So everything compressed in this file. You can unzip it. I assume you download this IDE from this link. Of course, this is free. The IDE includes a C and C++ compiler. After you download it, install it, open it, something like this. And then there are a lot of traces files. So the IAM file indicates the content in the cache simulator initially. So at the beginning, your cache content data. So you need to load these from your simulator, in your simulator. The trace file indicates the memory cache, which will happen in your simulation. So you can run the code like provide the file and run the application, debugging application from the IDE. I will show you how to do that. So you can click this button and set the argument to this button. I will also briefly introduce the simulator. I will give you the explain each state structure and explain each function. the purpose of each function. So I will do that now. So you can see this is the zip file. You can unzip it. Then you will have some file like this. So this file is simulator, and this directory includes all the image files and the trace files. I also have a tutorial for you, which includes the points I'm explaining right now. So you can check this tutorial yourself. I also includes this the PowerPoint I'm presenting now in this file. So you can also check that. Now I will continue to explain how to build this simulator. Assume that you download the code block and install the code block. You can have it like this. You can new a project. Like a console project. Okay, you can give it a name, for example, cache simulator. After you knew a project in this simulator, the simulator just give you a so you can close it. You can copy everything in this project2 directory to this cache sim directory. Delete this main file. Rename this cache file as main. And then open the code block again. You can open that. You can open this project file, the testing.ce. Or you can directly open that through this. Now you have this open your project of this code block, and then you can build it. So you can see that this file can be compiled. And then project. And then set the program's arguments. Because all you image file and the trace file are in this directory, so you just copy this. Let's try the A star. So the first parameter and second parameter. So you can see that we have those files in this direction. I'm trying and then OK. And build it and then run. So when you run the code, the code will first load the image file into the data structure of the tag, and then it will read that trace file and send the request one by one to this cache data structure, and then generate the heap rate. These are the heap rate. The first column is the heap rate for each level of cache. The second row indicates how many read operations you have. So totally in each trace, I have 1 million read operations. So some of them are hid in the L1 cache. Only the least one who have a missing L2. So I just finished the explanation on how to download the code, how to compile the code, how to run the code in the Windows. So all the things I'm explaining right now, you can find these in this correct. You can but even in the simulation like this by command line. If you use that this command promote application, you will open a console. You can run your application through that, even in Windows. So now I will expand the simulator. So first, we will load the image file. So this file. And then we create the three-level cache architecture. This first. So each initial cache function initialize the cache, of course. And then eventually we install. So the install means load the image file into the structure, so that you have some content in this. You have some data in the cache. You don't have the code miss. And then we load tree file. And then we send the tree one by one into these three level data structures. So you can see that if this file is open, send each request, each line, each line into cache data structure. So the request can be a read. It can also be a write. So the most important function is, of course, this single line. Because other sentences in the main function just initialize something, restore the data, and then send the data into the data structure. Let's see the access single line function. So this is the access single line. So before this one, we just do some checking. Whether this is a valid address, whether I can process this address in this cache. And then we do the lookup. The find function will help you to do the lookup. The key is the lookup. Key you get a key. So this key you have no key. So if you have a key, you will update the counter and then set some maintaining bits in the cache data structure. So when you have a key, when you have bits, you need to replace. You need to first look up whether you have a lower level cache. For example, if you are accessing the L1 cache, you will go to L2. If you are accessing the L2 cache. And then you also need so if you have a miss, you will need to do the replacement and look up the lower level. So do the update. So no matter you have a key or miss, you will do the update eventually. So let's see so there are three important functions. The first one is the find. It can help you to do the lookup. So this is the find function. The next one is the replace function. Probably you will need and then the update. I will explain these three one by one. So the find function, after you check this address, can be processed by cache. This is a valid address. It's just a lookup this tag, lookup the tag one by one. So if you can match the tag, you get hit. Otherwise, you just return -1. -1 is you didn't have hit, you have miss. The replace function to find the frame, which will store the new data. And then you install the new. So how to select that frame is decided by your replacement policy. You need to evict some wasted data, some old data, so that you can make that frame available, and then install the new data. So how to decide which frame is the has the wasted data is the key of your replacement. So here I provide you the most complicated that which is the least. So if you want to implement a randomly select a frame. So that's good enough. But here I give you the most complex. Of course, this is not cheap. In most, for most like most, so I will explain how this method works. So in this update, it will maintain the counter for all the cache. So for when you have a access, no matter it's a heat or miss, I will do this update. You can see that. No matter update function anyway. So in this update function, I just increase all the counters of all the cache items. When you have a access, I increase all the counters of all the things. And then I set the actual key, the counter actual key frame to 0. For example, I'm accessing this one. Then this counter is what does that mean? By maintaining these counters, the most recent user always have. But if your counter is a non-zero, is a larger than 0 value, you don't have the most recent used data. So during the replace, do I want to keep out this piece of data? No. Why? Because this is the most recent used data. So whose counter has a smaller value, who has more recently used. Then during the replacement, I just pick up the frame who has the largest value of the counter. So by these counters, I can maintain the information of the most recently used, least the most recently used. When you try to implement this, you can just simply modify the counter thing. Any question? Yes.
So the data structure to be created.
Yes, of course. The counter is made IDE. So what I'm describing here is all in this update. So no matter you have a heat and no matter you have need, you will write the update function in the access single line function. And then I just increase the counter to each frame by baseline. And then I reset the value of the most recent. Like this. If I never touch this one must have the largest value because this counter has never been reset to 0. Then during the replacement, I just pick up the largest value of the counter. Any other question? If no question, we can stop today. So this is a very short tutorial on the project tool. And if you have any question during the TA's office hour, you can go to his Zoom. You can write an email to him or me. I will stay here for maybe 10 minutes or 20 minutes. You can try it now. If you have a question, you can ask me now. Or you can leave, yes. Okay. So I have some comments. For example, the element is the trace element. So each element is one request in the trace. NCC record one is read or write. One is read. If it's 0, write. Then the address of the request, of course. And then we have a load operator. Write, store, write back. Write back means pick out something from your L1 cache. And then this one will write back to the L2 cache. So the cache includes LRU set. So this is the set associated with cache. The first of the instruction here is set. We have counters, we have tags, counters, and the address is free store. Better this address in the better this string is a clean or dirty means you have modified value also. This string. And then the cache instruction includes multiple set instruction. Because here we have a read. Besides this static part, we have a pointer to point out the lower level of cache. And then we have some associated line size, frame size, cache ID. These are just maintaining some maintaining the instructions. I don't think you need to modify that. And then the counters for me so the most important three functions is update, find, replace. Yes, the most important three functions. I don't think you need to modify find function, but it's just find the data you are looking for. you will find it, you will look for it anyway. So for you, the most important tool is the Applet. So try, read the code, try to run the code, and then come back to this classroom and ask me questions. And you can also ask a question to TA. So I have the paper of the midterm. If you want to pick up your paper, you can come here. You can follow. What's one part? Yes. That's right. Presented without a key break. Yes. No, you can input it all in one single file. That also works. You do some if else. Yes.
So are we just going to all of it? Or
Yes. You can do that. Or you can submit 3 files.
okay. Do you want us to do? Not just 2
3. You can have partner.
We can have partner?
Yes.
Oh, okay.
One, just one.